Okay, let's start. So we're going to continue with 6.1. Areas between curves. I think I kind of introduced this already. The idea is you're given two curves, f and g, and you want to find the area in between these curves on A, B, which the limits might be given to you, or they might be, so could be given, or you could have them determined by intersection points. So you could have something like f is doing this, g is doing that. You want to find the area between those. And then these intersection points tells you what limits you should do. Or you can have determined by intersection points. So in this case, what did we say the area should be? What's the formula for area? Yeah, integral.
X and x to the n plus 1.
What?
A.
A in the bottom, B in the top.
From A to B of what function? Right, so top function minus the bottom function. Dx, which in this case here would just be the antiderivative of f of x minus g of x. Dx between A and B. Right, because here if the function is on top, that's the f, the function on the bottom is the g, same here. Right, so this guy's the top, this guy's the bottom. So basically the idea is if you want to find the area between two curves, figure out who's the top function, figure out who's the bottom function, figure out what the limits are if they're not given, and you do that formula. And that's it in a nutshell. Of course there are other situations that you can have when you go from right to left, but in 205 we don't really deal with that. So this is pretty much all you need to know. Okay. So we did one example, and I wrote several others on the board, which I asked you to pull through. So let's actually go through those and see where we're at. So here, y equals 3 minus x, y equals x squared minus 9. And the question is find the area bounded by the curves. I may or may not ask this, but I could ask, for example, include a sketch of the region in your answer. So in general, if I don't mention this, you don't have to do it, even though it might be useful. But if it mentions you should include a sketch, you should include a sketch. So let's do a sketch. What's going on here? What does this look like? What does 3 minus x look like? What? What's 3 minus x? It's a straight line. How does it look?
Vertical.
Negative what? Negative what? Going this way? And through where?
Plus 3.
So this would be 3. What is this? How would you figure it out?
So it's 3.
What point is this called? What's this?
X intercept.
X intercept. How do you find an X intercept?
Setting y equal to 0.
Plug in y equals 0, you solve for x. What would you get? Okay. Now what does this guy look like?
Parabola. Positive parabola.
And what points would it go through?
Negative 9.
What are you telling me? Negative 9 comma 0. What does it look like? This should not be taking a long time.
Isn't the
It's
y
really something you should answer in 2 seconds, honestly.
Isn't the y-intercept 9 minus 9?
The y-intercept is minus 9.
Uh-huh.
Yes.
It's x squared. Yeah, but yeah, that's
Yeah.
It's going to intersect here. What's this point? Negative 3. And so this point here, we don't know that yet, but the area that we care about is the area between here. Right? So clearly you can see who's the top, right? You see that this guy here is the top function, so that's the line. The line is the top function, the parabola is the bottom function. So we want to integrate between the limits that bound the shaded region, which means I need to figure this guy out. How do I figure out that guy? Or we need to find the intersection. So once you have a sketch, the sketch kind of tells you who's the top and the bottom. Now you need to find the limits. So you know the limits are where they intersect, so you find the intersection points. Which basically means you're going to plug one function into the other. So I can take y equals this, and I can plug it into the y here. So x minus 3 minus x equals x squared minus 9. How do I solve that? Find the intersection points. I plug one function into the other one. That's how you find intersections.
Move the left side to the right side, so it's equal to 0.
X squared plus x, and that'll be minus 9 minus 3, so that's minus 12. So you bring everything to one side, say equal to 0, now what? Factor. What is it? X minus? Well, we know it's 4 and 3. What are the signs? Plus 4 and a minus 3, right? So you plus 4 minus 3 gives you plus 1, and then you multiply these, you get minus 12. So you get x equals minus 4, or you get x equals 3, and those are the intersection points. X equals 3 you already knew just by knowing how to graph these guys. So this guy here, now we just figured out, is minus 4. So this means that our area is going to be what? Antiderivative of? What are the limits?
From negative 4 to 3.
Negative 4 to 3. Those are the guys that are on the outer edge. And what is the function I'm going to integrate?
3 minus x. Minus x squared, parentheses, x squared minus x.
Right? So this is the top, and I'm going to subtract the bottom. Also note parentheses. So you do your sketch, which really should not be taking a long time at this point. Find your intersection points, it will help you get the limits, and then you integrate top minus bottom. And so we would have minus 4 3 of 3 minus x squared plus 9. I can combine these two. So minus x squared minus x plus 12. Now what? How do we do with this guy? What is this guy? Power rule, what do I get? X cubed over 3, this guy. Squared over 2, this guy. 12x, and you write that line. And so now you just, what do we do with those numbers? Now what?
Plug in the top.
Plug in the top number, the 3, you plug it into the function, plug it into the whole function. So you get minus 3 cubed over 3, which is just 3 squared, minus 3 squared over 2, plus 12 times 3. Then what? Minus
-4 squared.
Now you're going to plug in the bottom number, parentheses, important. And then you plug in the bottom number into the function. So you have minus 4 cubed over 3, minus 4 squared over 2, plus 12 times minus 4. And then you just compute that answer, which I think I already did. So let me just tell you what the answer is. So you'll do that, you get 243 over 6. When you create the common denominator and all that. That's the area between the curves. So that would sort of be a typical area problem. You say, oh, include a sketch in your answer, find the area between these curves. In this case, you weren't given bounds, which means you have to figure them out, which means the area would come from your intersection points, which you plug one function into the other to figure those out. And so again, graphing, algebra, solving this, algebra, this is calculus, and then that's arithmetic. Let's do another example. Here are two functions. Find the area between y equals x squared and y equals 2 minus x squared. Here I'm giving you limits, 0 to 2. Include a sketch in your answer. Shade the required region. So you're going to sketch it, you're going to shade the region that you want to find the area of, and then we're going to start to set things up. Okay, what does y equals x squared look like? Triangle. What does y equals 2 minus x squared? Upside down parabola. How high does it go? It goes up to 2. Okay, what area do we want? Okay, so how far does that go? see where they intersect? Are you sure? Are you sure? You're positive? Where do they intersect?
You wanted to plug them in each other.
Let's find those intersections. How do I find the intersection? Okay, and what will we get? We get x squared equals 2 minus x squared. How do I solve that? So I will get 2x squared minus 2 equals 0, which gives me. That's just basically x squared minus 1 equals 0, so I get x equals plus or minus 1. Right? So this guy here is 1, this guy here is minus 1. So where do we have to go? From 0 to what number? To 2, which is more than 1. Right? Which means the required area goes all the way. Kind of widen this. The required area is actually this guy. There are 2 sections to this area that I just asked you to find. Now what? So the area is going to be what? Sure, it's the integral of top minus bottom, so what does that mean here? They switch. Yes, that is an important fact to notice. Notice that on this side, the top is the 2 minus x squared, right? And the bottom is x squared. But when you're over here, x squared is the top and the bottom is 2 minus x squared. That's actually important. Your top switch, how do you deal with that situation?
Square minus 2 minus x.
What? Okay, so what do I do here? What's the first? What?
From 1, no?
From 1? 0 to 1, and then what? Okay, but 0 to 1 of what?
Or you put the top minus x squared. X minus, I mean the 2 minus x squared. Minus x squared.
Alright, so this here is the top, and that's the bottom on the interval 0 to 1. Plus, now you want to add a second area, which is going to be 0 from 1 to 2. And what's that? Then you switch them. This is going to be x squared minus 2 minus x squared. Because the bottom and top actually switch here on you, but you should always be integrating top minus bottom. That's how you find the area. So if your top switches, you need a whole other integral to deal with that section. And so this is basically the integral from 0 to 1 of 2 minus 2x squared x plus integral from 1 to 2 of 2x squared minus 2 dx. One thing you can notice is that this one is going to be the negative of that one, right? So if I do all the work here, I know that's just going to give me the negative. So what's this? 2x. 2x cubed over 3. That's between 0 and 1 plus. Remember, it's the same thing, so I'm just going to take the negative of this. It's minus 2x minus 2x cubed over 3. And that one is between 1 and 2. What I do in the first case? By plugging 1, I get 2 minus 2 times 1 cubed over 3 minus. You plug in 0 here, you get 0. Right? So that's just the first section. I did the fundamental theorem of calculus. Now I'm going to do the second section. Plus plus, and I'm going to do the second part, where I'm going to plug in the 2 for x. Minus, I'm going to plug in the 1 for x. So that is 2 minus 2/3 minus 4 plus 60/3 plus 2 minus 2/3. And do that. I did it here already. So it's actually worked out to be an excellent section. So you just add all the integers to that. This actually kills those. So it actually wasn't that bad. You have 16/3 minus 4/3, you get 12/3, which is good. Questions? So if limits are given, pay attention, because it might not be that the intersection points are really what's going to tell you what to do. If limits are not given, then you kind of rely on the intersection points, because there's no other way to really determine where you want to stop. Let's do another one. Okay, what do we do? Let's do a sketch. What's this guy look like? What is it? It's a parabola? Where does it go through? What are the X intercepts? So I know it goes through 0 and it goes through 2, so it's pretty much like it goes through 0 and 2, then what? This guy, what does that look like? So the y-intercept is 4 and it's a positive slope, positive 1, so it's assumed it looks like that, where this is going through 4. So that's the area that I want. They never gave me any intervals, so I'm just going to assume that I want the area between these curves. So those two numbers I'm going to have to figure out. How do I figure out those numbers? You plug one into the other. So I just set this equal to that. X squared minus 2x minus x plus 4. So that x squared minus 3x minus 4 equals 0. How do I solve that? What do I do now? Factors. What do you get? I've assumed 4 and 1 would work. Minus 4 plus 1, so my x is either 4 or my x is minus 1. So this guy here is the minus 1. And this guy over here will intersect at 4, which means that my area would be
integral 1 to 4.
Minus 1 to 4 of
X plus 4.
the top function, x plus 4,
Minus x squared minus 2.
minus the bottom function, you need the parentheses here, x squared minus 2x. Which is minus 1 to 4 of x minus plus 2x, that would be 3x plus 4 minus x squared. Okay, what does the first term become? Yeah. Now what? Plug in 4. Minus parentheses. Plug in 1. Negative 1. And you have to be careful with the signs here. The minus 1 squared gives you plus 1, but this will make that a negative. And minus 1 cubed is negative, so this is then going to be a positive. But find the common denominator and all that, and you will get 125 over 6. Hopefully you're starting to see a pattern here. Get a picture. Find the intersection by plugging one function into the other. That's going to be algebraic factor. It's going to be a quadratic, usually maybe a cubic, but usually a quadratic. Then take the integral of top minus bottom between the required limits. If you're given limits, you have to worry about, do the intersections actually cover everything, and does top and bottom switch or anything like that. But after that, it's pretty much, yes.
What do you put x to the 4? I mean, for x, from where you did that. The 4x.
From over there?
Uh-huh.
Here, this is 4. The antiderivative of 4 is 4x.
Okay.
Remember the antiderivative of any constant, just constant
Okay.
times x.
Okay.
Right? Because the derivative of 4x gives me 4.
Mm-hmm. Okay.
Other questions?
Can you do one with the absolute value?
I could do one with an absolute value, sure. Find the area bounded by y equals absolute value x. Y equals x squared minus 2. Absolute value x looks like what? So b. X squared minus 2 is just a parabola that goes down to minus 2. Of course, the intercepts, we don't really care about those intercepts, we kind of care about these. So this is the area that I care about here. Let's find those intersections. And what do those give me? Well, there are two possibilities. So I'll either have x is equal to x squared minus 2, or minus x is equal to x squared minus 2, depending on if my x is positive or my x is negative. So I just split up the absolute value by the definition. Right? So, and notice by the way, one is just going to be the negative of the other. So I solve this guy. So I get x squared minus x minus 2 equals 0. Try to factor that. 2 and 1 seem to make sense. Minus 2 plus 1. So I get x equals 2, or x equals minus 1. And so that was for the positive side though, so that means that 2 is the guy I want here. If I solve for minus x equals x squared minus 2, I will get x squared plus x minus 2 equals 0. So I factor that. Again, 2 and 1, but this time plus 2 and a minus 1. So x equals minus 2, or x equals 1. But this is for the left side, so I want a negative x, and this guy is going to be minus 2. So now you have a couple options here. Basically just do it directly. Take here and use the integral of top minus bottom. In which case you have a different one from this guy as opposed to that guy. Right, so if you're looking in this region here, the top function is this, which is the function minus x. And the bottom function is the parabola x squared minus 2. So you'll have minus x squared minus 2. On this side, the top function is x, the bottom is x squared minus 2. So here I have x minus x squared minus 2. And you can compute that. Another option is to just notice that this is actually symmetric. Right? Like this half is exactly the same here as that half. So I can just focus on one side and double the answer. So that's because it's exactly symmetric.
You will save top minus bottom?
Yeah, but it'll only be the top and bottom for one side, and then I just double the answer. So it'll cut my work in half. Another option is to use symmetry. And so you realize that the area is just actually the double from 0 to 2 of the right side. So it's x minus. Antiderivative of that guy is going to be x squared over 2, x cubed over 3, x times 2. Plug in 2, get 2 squared over 2 minus 2 cubed over 3 minus 2 times 2 plus 2 times 2. And if you plug in 0, you get 0. Minus 0. Can't fit here. Did you guys copy this down? Go ahead, now. 2 times, that's a 2 minus 8 over 3 plus 4 plus 2, that's 6 minus 8 over 3. 3 6 is 18 minus 8, so that's 10 over 3. So 20 over 3 would be the answer. Here's one. What happened?
You gotta do curve sketch.
You gotta do curves.
That's impossible.
No, that would be hard. You factor out an x,
Oh, yeah.
and
But we still get it, though.
I mean, technically you don't have to sketch that, but if you wanted to, it wouldn't actually be that bad if you look at it. I don't think. 3x cubed minus x squared minus 10x. I just think of that as this. Does that factor? Hopefully. Maybe 2 and 5. So I would need a minus this plus that. And so I get x equals 0, x equals minus 5/3, and x equals 2. Use the graph of that. Just look like this. That's a 2, that's a 0, that's a minus 5/3. So you can do a naive sketch from pre-calc. The important thing here, though, is notice that the question didn't say sketch the curve, right? So if you're reading carefully, which you always should be reading, if I don't ask you to sketch it, you probably wouldn't need to sketch it. So I kind of gave you that example to see, well, if you don't have to sketch it and you really don't want to, like you'd see this, you know, I don't want to do that, there's actually a way you can get around sketching. So I put that example in there. Last time I wrote that on the board, I say, hint, do not sketch. So if you're not going to sketch, how do you do what you need to do? And so you could sketch if you wanted to, but it's not really necessary, and I never really asked for it, so you wouldn't really have to give it to me. So without sketching, recall, you just want to know, you want to find the area, right, which you know is the integral of top minus bottom. Now, one of the reasons what this sketch helps you with is figuring out who's top and bottom. You just look at the picture and say, oh, that's the top, that's the bottom. But if you have another way of figuring it out, right, you could use a sketch to figure this out. But there are other ways, or how else do you think you could figure it out? Well, basically, top is the guy who has the higher y values, right? Right? That's how you know something is the top. It has higher y values than the other guy, right? The y values are higher means he's above the other guy. So basically, all you have to do is figure out which y values are bigger for which function. That's basically the idea. So here what you can do is you can just test points. Right, so without a sketch, you can figure out who's on top and who's on bottom by seeing who has the highest y values. So let's actually test the points. But now the question is, what points do we test? Well, I wasn't given any interval to test on, so let's actually just find the intersections and test around those. So what will be the intersection points here? I erase the curves, let me recopy them. So I'll get 3x cubed minus x squared minus 10x equals minus x squared plus 2x. Which means here I have 3x cubed. Bring this guy over here, what would happen? It would just die. And so I have minus 10x, and I move the 2 over here, I get minus 12x equals 0. So the common factor is 3x. I would be left with x squared minus 4. Right? So I have x equals 0, or x equals plus or minus 2. So now what I'm going to do is on this interval, minus 2, 0, and 2, I'm going to see who's bigger. Right? So let's say y1 is the cubic. y1 is 3x cubed minus x squared minus 10x. y2 is the parabola, minus x squared plus 2x. So what you're going to do is in this interval, pick a random number in this interval here, like minus 1 for example, and see what each one gives you. So y1 of minus 1 would be, plug in minus 1 here, I would get what? Minus 3, minus 1, plus 10. Right? So that would give me what? Positive 6. If I find y2 and I evaluate it at minus 1, I would get minus 1, minus 2, which gives me minus 3. Right? So you see over here, the top is the cubic. It gave me the higher y value in that region. Over here, I plug in another random number, like a 1. If I plug in a 1 into the cubic, I would get 3 minus 1 minus 10. That gives me, what, minus 8. If I plug in the 1 into this guy, I get minus 1 plus 2, that gives me plus 1. So over here, you see the top is a quadratic. Right? So even without sketching it, I can figure out who's the top. So between minus 2 and 0, the top is the cubic function. Between 0 and 2, the top is the quadratic function. And I can figure that out without sketching. All I have to do is see who gives me the higher y values. And with that being said, I'll now be able to figure out my error. My error is going to be between minus 2 and 0. It's going to be the cubic function. Minus the other function. Plus, from 0 to 2, it's going to be the quadratic function minus the cubic function. Just remember, one is going to be the negative of the other, so if I just work on one for a while, I can sort of skip to the other one. Here I would have, let me simplify this a little bit, 3x cubed minus x squared minus 10x. So let me just start adding these. This will give me a plus x squared. Which kills equals this. This would be minus 10 minus 2x, so this just becomes minus 12x dx. And I would find the antiderivative of that, which is going to give me 3x to the fourth over 4 minus 12x squared over 2, which is just 6x squared, between minus 2 and 0, which means I know what this side would give me. So it's going to give me the negative of that, minus between 0 and 2. So here, if you plug in 0, you get 0, minus, plug in 2, I get 3 times 2 to the fourth, which is 16, minus 6 times minus 2 squared, plus, plug in 2 here, minus when you plug in 0. Two, figure out some so that's actually 2. You do the common denominator and all that. Alright, so that's an option. If you're not asked to sketch it, you actually don't have to. You can just find the intersection points, draw your interval, plug in numbers in between the interval into each function and see who gives you the higher y value. The guy who gives you the biggest y value in each subinterval is the top function. And so you just hit the top minus the bottom. But basically what you want to get into your head is error between two functions, integral of the top minus the bottom. The limits come from either the intersection points or the intersection points and another interval that you may be given. But that's kind of all there is to areas. It can get a bit more complicated, but we're not going to do the more complicated version. Actually it. We finish this over. Let's work for a second, but we're time to spare. Yeah, we're like done. We're done with everything. I'm serious. No. But as for the next test, it was scheduled for Monday. You guys want to do it Wednesday?
No, Monday.
You guys rather?
Wednesday.
The 14th is our final. What?
Oh yeah. Wednesday.
So the 14th is the final?
Yes. We don't actually have a class on the 14th, it's fine. The last class is the 12th, which is next week, Monday.
That day is Wednesday.
And that day would be the test. Unless you guys want to do it Wednesday, and then on Monday we can have like a final review or something. What? A review plus the test? Sure.
No.
But it would be like-
For the test. Review for the final. Review by review.
That's all.
For the pre-final.
Okay. All right, we could also do that. As for also the final, I should probably talk about that. The final is, as I said, it's December 14th. Let me remind you of that. So the final is December 14th. That's a Wednesday. And it's from 8:30 to 10:45. I did not pick the date or the time. That's just what's given in the final exam schedule. So it'll be 2 hours and 15 minutes long. It'll be something like you have to do 8 or 9 problems in the whole final. There's going to be a compulsory section and an optional section. Yeah, but I'll talk more about the final after. I'll probably even draft a mock final. What? Okay. You guys have another option, but it's kind of has to be by unanimous decision. So it's, if one person can't do it, then it'll get scrapped. You could do the final on December 20th. The thing is that would be a Tuesday, but the nice thing about that, it would be from 6 to 8:15.
Which test would be harder?
So it's this, if anyone has a problem with that. Okay, so it's that.
Who makes the is it going to be two different finals or the same?
It would have to be 2 different finals. I'm doing it on 2 different days. That's
Are you making out finals, right?
Yep, I'm writing.
Is it harder on that day since we get more time? So I just want to know, because that one is really.
We're ending at 10:45. You want more time? Just to go at midnight.
We're not getting a fraction.
No, I'm saying, is it harder? Are you going to put more on that one?
No, why would I do that?
We're not getting a fraction for the curve sketching, right?
Then you want them December 20th.
No, he has like an exam or something. You'll final at the same time on. Okay, all right. So that's it. So on Wednesday we'll do review. The last test is on Monday. So it'll cover everything in the syllabus. So you have to know Riemann sums, finding integrals, definite and indefinite, of course using substitution, and the basic rules, and area between curves. That's pretty much it. No, curve sketching was on the last exam. So on Monday it's, yeah, so Monday that's it. Riemann sums, area between curves, and integrals, definite and indefinite. I will see you guys on Wednesday.
Sorry.